Assalamualaikum warahmatullahi wabarakatuh. Shalom, Om Swastiastu, Namo Buddhaya, wishes of benevolence. May peace, mercy, and blessings be upon you. Greetings everyone, we are honored to present our project titled Steering Towards Knowledge, Project Best Learning with Cross-Border Line Follower Robot. This project is a part of our final exam text in programming learning, guided by our esteemed lecturer, Mr. Iqvi MDRT. It is hands-on initiative aimed at introducing students to the foundational concept of robotics engineering. By merging programming knowledge with practical application, this project serves a platform for students to develop skills in robotics and automation. The Cross-Border Line Follower Robot is not just a tool for experimentation, it represents an opportunity to understand our real-world problem solving. Through this project, we aim to enhance our abilities to learn, analyze, and address challenges related to programming while exploring how robotics can be used to innovate and improve systems around us. First, let me introduce myself. My name is Allyssa, Naura, Salsabila, a shared company for today, and my team member, Akbar, Iqvi, and Shinta Dwiyani. Let's move to our table of content. First, we have programs, algorithm, and second, we have in-depth program explanation that is half 4 points. First is definition and declaration, then switch and case, line reading logic, and last, point motors and servo. Let me explain to you our program's algorithm. This algorithm describes the operation of a Cross-Border Line Follower Robot equipped with functionalities for detecting intersection, following a track, and performing specific action. The robot is guided by a sensors, servo, and programmed to execute action based on a specific pattern or inputs and environmental triggers. The robot will start to initialize the 3 variables, that is, pattern, intersection, and checkpoint to 0, and after that, the line sensor will detect if it's the sensor 1 and the sensor 2 are high, it will turn left. If it's sensor 4 and sensor 5 are high, it will turn right. And if it's sensor 3 or sensor 3 and sensor 2 or even sensor 4 are high, it will forward. And then the robot will follow the line. If 5 sensors are detected, it will count as intersection 1, and it will move forward and following the line. And if the sensor detected all the 5 sensors, it will count as intersection 2, turn left for 1 second and following the line, and known as a checkpoint 1. And after that, if all the sensors are detected again, it will count as an intersection 3 that will go forward and pick up the tree with the gripper and forklift and move backward and following the line. And there is an intersection 4 if the sensors are detected all the sensors for the 4th time, it will turn right. And if all the sensors again detected for the 5th time, it will put the gripper down at the forklift and put the tree, move backward, and there is intersection 6 that will move or turn left into and following the line. And after that, there is intersection for the 7th and the 8th time for the round lines that will be detected, and so it can be moved and following the line furthermore. And after that, the others and the last intersection for our line and guide, it will move and pick up the marbles and put them into a basket using the forklift and a gripper. It will have 4 marbles, and it will be a bonus point that if the robot can do all of that. That will be the end. Now let's move to our program's explanation. First, we have definition and declaration. First, there is a library's endpoint declaration. The servo point H library is included to control a servo motor that use for taxi requiring angular movement like a gripper. And then we have motor driver pins. Enable A, 3, enable 1, 2, into 4 for control the first motor for movement. That is the left wheel. Enable B in 3 and in 4 for controlling the right wheel that connected to the motor driver to control speed using PWM and direction. And then line sensor pins. Sensor 1 to sensor 5 connected to pins 8 to 12. Sensor to detect the line beneath the robot that they return digital values high or low, indicating whether the sensor is over a line. And there is a forklift motor pins. Motor pin 1 that is A0 and motor pin 2 that A1 that control a DC motor for the forklift to pick up or drop the objects. And then after that a servo motor pin. Servo pin that is pin 13 or control a servo motor and initialize to 0 degrees and the setup function. And there will be button pin at the A5 used to detect the user input to switch between modes, checkpoint or text. And there is a variables or global variables. First, we have a checkpoint variables. Checkpoint is a track robot's current checkpoint or attacks. It will be button press, tumble status, or tumble tracking. And there is a line detection and path memory. Line detected is indicate if a line is detected. Path memory is a way to store processing information. Left it's 1, like right it's 2 or straight it's 0 or 3, and for the example it's like that. And there are memory index to keep tracks of the array index for the path memory. And intersection or simpangan variables count detected intersection and differentiation between left and right turns, and ensure an intersection is processed only once. And then there are a setup function. There are motor pin initialization to set all the motor pins. Enable A in 1, in 2, enable B in 3, in 4. Motor pin 1, motor pin 2 as outputs that used to control the motor speed and direction. Second is sensor pin initialization. To set the line sensor pin, sensor 1 to sensor 5 as input. The sensor will connect it to Arduino Uno and used to detect the black line and the white line on the ground. And there are a servo initialization to attack the servo motor to servo pin and initialize the servo position to 0 degrees or default position. And there's a button initialization that compares the button pin as an input with a pull-up resistor, or in here we don't need a resistor, so we just connected the button pin with the jumper cable, and if the button pin are high and press, it will following the program that have been exactly told. And there is a serial communication that initializes a serial communication at a bump rate of 963 9000 and 1600 for the picking and heavy sensor.
Okay, I want to presentation about void setup. Void setup. Explanation of void function. Number 1, hardware initialization. Inside setup, you can configure analog or digital pin, initial serial communication, start sensor, or configure other hardware that will be used during the program execution. Number 2, called only once. The setup function is called only once when the program first start or is reset. After that, the program will be processed to execute the log function. Set the pin motor as output. Pin mode enable A as output, pin mode input 1 and 2 as output, pin mode enable B as output, input 3 and 4 as output. Pin motor enable A and enable motor B are commonly used in controlling DC motor with motor driver. Next, set the sensor pin as input. Pin mode sensor 1, 2, 3, 4, and 5 as input. Next, set the pin motor DC 4 clips as output. Pin mode motor pin 1 as output and motor pin 2 as output. Next, initialization servo. My servo attach servo pin. My servo write 0. 0 indicate the initial position of the servo. Next, serial communication. Serial begins 9600. Serial begin 9600 is a command in the Arduino programming language used to initial serial communication between the Arduino and other devices, such as a computer or other modules, with a baud rate of 9600 per second. Okay, void loop is the main function in an Arduino program used to execute commands repeat after the setup function has finished running. This function will continue to loop as long as the Arduino is powered on and not reset. Here, we want to use a push button as a checkpoint reminder. The programming code is as follows. When the button is pressed once, it will immediately read the first checkpoint, and when the push button is pressed again, it will read the second checkpoint, and so on. Next, when all sensors are in a high status, this condition is called a deviation. The deviation is created according to the exiting track. Here, we use the switch and catch programs. So, as we can see here, if sensor 1 high, sensor 2 high, sensor 3 high, 4 high, and 5 high, if simpang process is true. So, switch deviation under case 1, serial print move forward. Next, case 2, serial print turn left, and so on. However, there is a difference when the robot is about to pick up a marbles. In this case, where only 4 sensors are in a high status, we create the program for this deviation as follows. If sensor 1 low, sensor 2 high, 3 high, 4 high, and 5 high, or sensor 1 high, sensor 2 high, sensor 3 high, sensor 4 high, and sensor 5 low. If simpang process, simpang true, and serial print switch deviation under case 1, 2, 3, and so on. Okay, that's all for my presentation. Thank you.
Next, I will explanation about line leading logic. For the line leading logic, first it will be declaration S1 is a sensor 1 until S5 as a sensor 5. And for the logic, if sensor 1, 2, 4 and 5 is 0 and only S3 is 1, it will be move forward. As the same for S1 and S5 0 and S2, S3 and S4 1. And then else if for the turn right it was only S4 or S5 and S1 and S5, S3 and S4, S3 and S4 and S5. That was for the turn right. Or the turn left, it was S1 or S2, S1, S2, S1, S2 and S3, and also S1, S2 and S3 and S4. And for the last, it was move backward. If it will be moved backward for if S1 until S5 is 0. Next, it will be the motor DC function. For the going up for clip and going down for clip. For going up, the motor DC pin 1 it will be high and pin 2 it will be low. For clip down, it will be motor pin 1 it will be low and motor pin 2 will be high. For the move forward, in 1 will be high and in 3 will be high. For the in 2 and in 4 it will be low. For the turn left, in 1 low, in 2 high, in 3 high, and in 4 low. It will be the motor 1 or motor A will be going backward, and for the motor B will be going forward. For the turn right, in 1 it will be high, and in 2 low, in 3 low, and in 4 high. For the turn right, the motor A will be going forward and the motor B will be going backward. For the stop motor, in 1 low until in 4, because if low, all of them low, it will be stop the motor. For the servo setting will be going close if the servo going to 70 derajat, and for the servo for the 3 will be closing if the servo was 65 derajat, and for the servo going open it was on 0 derajat. Thank you.
conclude, let us reflect on the significance of this project. Through the development of the Transporter Line Follower Robot, we have not only explored the technical aspect of robotics and programming, but also engaged in critical thinking, problem solving, and collaboration. This project has demonstrated how integrating engineering principles with practical application can pave the way for innovative solutions and deeper learning. We extend our gratitude to our honored lecturer, Mr. P. Amalia Pateha, MDRT, for his guidance and support throughout this journey. His insights have greatly contributed to the success of this project. Thank you for your attention, and we hope this project inspires further exploration and innovation in the field of robotics and programming. Let us continue striving towards a future shaped by creativity and technology. Wassalamualaikum warahmatullahi wabarakatuh. Shalom, Om Santi Santi, Om Namo Buddhaya, wishes of benevolence.